We have worked on inequalities for several weeks now, and we need to go back and review how you solve and graph inequalities. So, we're going to start by doing a one-step inequality. And as I look at this, I have a plus 21, so I need to subtract 21 on both sides, just like I would as if there's an equal sign there. This goes away, leaving a, and now instead of equal, I have to remember to bring down the inequality sign, and the answer is 16. So a is greater than or equal to 16. That's the solution. If I look at number 2 is written backward, so to speak. However, as long as I keep the inequality sign as is, when I solve this, I can go ahead and solve it as is. So I'm going to divide by 5. Remember, I want to start on the side that has the variable. And I'm going to divide by 5 on this other side, leaving 7 is less than x. Now, if it bothered you to see this written backwards, we can switch sides, but when we do this with an inequality, the inequality has to switch sides as well. So this would be 5x is greater than 35 as opposed to 35 is less than 5x. So let's see what happens when we work this out this way. We get x is greater than 7. So if I look at this, these are all the numbers that are bigger than 7, and this means 7 is smaller than all of these numbers. So actually these two statements really mean the same thing, because these numbers are bigger in either situation. The next inequality is a two-step inequality. So we're going to drop our line, and we're going to add 6 using the constant to both sides. This adding 6 undoes the subtracting 6, leaving negative 4y on this side is greater than 20. So our second solving step, we have to divide, but if we're multiplying by negative, we have to divide by negative. And this is where things change in an inequality. If we divide or multiply by an inequality, the sign switches. Just like an equation, these two cancel each other out, leaving y equals, and this should be a 20. 20 divided by negative 4 is negative 5. So when we divide or multiply by negative, when we solve inequalities, it switches the sign. So this should read y is less than negative 5. For our next set of problems, we're supposed to graph the following inequalities. And the first thing we need to remember is how we do this. And we do this by first building a line. So if I look at number 4, I'm going to key off the solution number. So I'm going to put 15 in the center, and I'm going to show a couple numbers above 15 and a couple numbers below 15. The next step involves deciding whether I need an open circle or a closed circle. And if I'm given less than or greater than, it means that 15 cannot be included. But if I'm given less than or equal to or greater than or equal to, it does include the 15. So if I look at this symbol, it does not include 15. All of these numbers are less than 15. So I have to put an open circle. So that was step number 2. Step number 3, now I have to decide which side makes this inequality true. And these are all the numbers that are less than 15. So I'm going to test a number. I think 13 is less than 15. And the reason I know that I'm reading less than is because I see the smaller part of the symbol first. And that is a true statement. So I want to darken in this side and darken in the arrow. So let's start this process over again with problem number 5. First, let's try that again. First, we want to build the line. So if I look at this, I'm looking at negative 2. So I'm going to put negative 2 in the center. And when I build the line, I have to recall as I go up the line, I'm really looking at what looks like to my brain as smaller numbers. And if I go down the line, I'm really looking at what looks like to my brain as bigger numbers. But on the negative side, they get smaller as we move to the left and bigger as we move to the right. So after I build the line, I now want to go ahead and do the second step. So the second step says that I want to open circle for less than or greater than, and a closed circle for less than or equal to, and greater than equal to. So I'm going to look at this sign. I see a greater than or equal to, so on the number that I'm looking at, I'm going to darken in that circle, which means I'm including negative 2 because it could be also equal to negative 2. So that's step 2. Step 3 asks me to choose the side that makes this true. So I need all of the numbers that are bigger or larger than negative 2. So if I tested, say, 1, for example, 1 is greater than negative 2. Any positive number is bigger than a negative number. So I'm going to darken in this side of the line. Finally, problem number 6 reads, Maisie needs at least $40 to buy a pair of shoes she really wants. She has already saved $23. So we're going to consider that she has $23 in her pocket. If she charges $5 per hour to babysit, determine the minimum number of hours, H, there's our variable, she needs to babysit in order to buy the shoes. So if we look at this, this is the total she needs. At least she already has $23 saved, and $5 per hour, with H being the variable, supports all of these inequalities. So $5 per hour plus the 23 she has, and a total of 40. So what we're really looking for is the inequality signs. That's what we're going to have to key off of. So let's use our logic to eliminate some of the examples they've given us. So if I look at this inequality sign, it says the amount that she's going to go in to buy the shoes is less than $40. But she needs at least $40, so she can't have less than $40. This one, once again, here's the amount that she's saved or has earned, and I see that it's less than or equal to $40. Well, it could be equal to $40, but once again, if she wants to have at least $40, it can't be less than $40. So that eliminates this one. Choice C. Once again, this is exactly the same. She's babysitting for 5 hours, earning $5 per hour, and she already has $23. And we want to know if she could have greater than $40. Well, it does say at least $40. So yes, she could have greater than $40. That would be able to allow her to buy the shoes. So maybe C is a possibility. So we're going to look at the last one. This says that it's greater than $40, and we've already established that yes, she wants to have greater since it says at least, or this one also says it could equal $40. And since at least is $40, this is the best choice. So answer D fits the bill. In the next coming days, we'll take our first quiz on inequalities, and many of the problems will be exactly like the review we just completed.